Well, hi everybody, hope you're doing well. This video here is about using logarithms to solve an exponential equation. If your equation has your variable, your unknown, as an exponent, you're going to use a logarithm to solve it, most likely. So I'm going to start this video off with a little bit of a fact here, and the fact is that log functions and exponential functions are inverses of each other. We've talked about this quite a bit in class. Here is another kind of a more practical application of this fact. Since they are inverses, what this means is that they undo each other. That is one of the qualities of a pair of inverse functions, is that one of them undoes the other one. But what that means for us, since we're solving an equation, is that if you need to undo an exponent, you're going to use a logarithm to do that. Okay? Let me show you, and you are familiar with this process of using the inverse operation to solve an equation. You've done that many, many times. Let me show you a couple of simple examples. Let's say you had x plus 10 equals 50. You know exactly what to do with this. You hardly even have to think about it, probably. You're going to use the inverse process for addition, which is subtraction, and subtract 10 from both sides, and you get x equals 40. What you did was you took advantage of the fact that addition and subtraction are inverses of each other. Okay? That's what we did. That was a very simple example. Let's try another one. Let's say we had 10 times x equals 50. Well, you again know just what to do. You're going to undo that multiplication by division, because division and multiplication are inverse processes of each other. They're inverse operations, and that's how you undo multiplying, is by dividing. Well, okay, what if your equation was 10 to the x power equals 50? What's the inverse process for raising to a power? And that's what we're talking about here in this video, is that exponents and logarithms are inverses of each other. And so we're going to use the logarithm to undo the exponent. We'll make another video maybe about using the exponents to undo the logarithm, but we'll get to that some other time. So what I want to show you here is how you're going to do it. It's pretty easy. I'll show you. Let's take a look at that same example there. 10 to the x power equals 50. Well, since my variable, my unknown, is an exponent, I'm going to use logs. I'm going to take the log of both sides, all right? That's my first trick in solving an exponential equation, is to take the log of both sides. Now, the next thing is this may ring a bell for you. You have log of 10 to the x power, and you can rewrite that as x times log of 10, right? There's this little thing that we have, a little property of logarithms. Sometimes we call it the wraparound rule. And it means that if you have log of something to a power, that exponent, can be rewritten as a coefficient of the logarithm. So I've got x times log of 10 equals log of 50. Well, my next step here, what happened to the log of 10? Why is it that just disappear? Well, you might remember that log of 10 equals 1. So I was really just multiplying by 1 there when I had x times log of 10. And x just equals log of 50, which if I get my calculator out and figure out what log of 50, it's about 1.699. And so there is my solution. I could also say my solution is just log of 50, because that's an exact expression for it. But if I wanted to round off to, let's say, 3 places, 1.699. Let's do another one. Let's say, slightly more complicated here, 2 times 5 to the x equals 60. Well, I didn't mention this before, but it's super important that before you take logs of anything, you isolate that that exponential expression. You isolate that first. It's kind of like that you're undoing the order of operations in reverse order. We had 2 multiplying 5 to the x, so we wanted to get rid of that 2 first by undoing the multiplication. That is, by using division, the inverse process. So I have 5 to the x equals 30 when I divide both sides by 2. And now I'm going to take the log of both sides. I got log of 5 to the x equals log of 30. Once again, my wraparound rule will give me x times log of 5 equals log of 30. And still, now we're back to multiplication. I undo the multiplication with division. So I divide both sides by that log of 5. And so my answer really, in its most exact form, is log of 30 divided by log of 5. Now I can get my calculator out and get an approximation for that. 2.1133, and I could go on forever on how many decimal places I want, so I just picked 4 here. But there's my solution there to 4 decimal places. Okay, let's do one more. This one's got a little more complicated looking exponent, but I'm going to use base 10 again just to kind of make things easy. So I've got 10 to the x minus 3. My exponent is x minus 3 equals 185. I'm going to take the log of both sides once again because my exponential part is already isolated there, so no problem there. But now when I use that wraparound rule, it's the whole thing. X minus 3 is the exponent, and that's the exponent of 10. So that whole x minus 3 expression comes down to multiply log of 10, which we already said log of 10 equals 1. So my equation really kind of simplifies down pretty quickly to x minus 3 equals log of 185, which on my calculator is 2.2672 ... and so I'm looking for x, so all I have to do here is add 3 to both sides, and there's my answer. And so that's it. It's a pretty simple process. I hope you got a little bit of benefit out of watching this little video here. Be sure to ask a question in the forum if you have one, and we'll see you soon. Be well. Bye-bye.